Density altitude is the altitude relative to the standard atmosphere conditions at which the air density would be equal to the indicated air density at the place of observation. In other words, density altitude is air density given as a height above mean sea level. Density altitude can also be considered to be the pressure altitude adjusted for non-standard temperature. Both an increase in temperature, decrease in atmospheric pressure, and, to a much lesser degree, increase in humidity will cause an increase in density altitude. In hot and humid conditions, the density altitude at a particular location may be significantly higher than the true altitude. In aviation, the density altitude is used to assess the aircraft's aerodynamic performance under certain weather conditions. The lift generated by the aircraft's airfoils and the relation between indicated and true airspeed are also subject to air density changes. Furthermore, the power delivered by the aircraft's engine is affected by the air density and air composition. Aircraft safety. Air density is perhaps the single most important factor affecting aircraft performance. It has a direct bearing on the lift generated by the wings. A reduction in air density reduces the wing's lift. The efficiency of the propeller or rotor, which for a propeller behaves similarly to lift on wings. The power output of the engine. Power output depends on oxygen intake, so the engine output is reduced as the equivalent dry air density decreases and produces even less power as moisture displaces oxygen in more humid conditions. Aircraft taking off from a hot and high airport such as the Quito Airport or Mexico City are at a significant aerodynamic disadvantage. The following effects result from a density altitude which is higher than the actual physical altitude. The aircraft will accelerate slower on takeoff as a result of reduced power production. The aircraft will need to achieve a higher true airspeed to attain the same lift. This implies both a longer takeoff roll and a higher true airspeed which must be maintained when airborne to avoid stalling. The aircraft will climb slower as the result of reduced power production and lift. Due to these performance issues, a plane's takeoff weight may need to be lowered or takeoffs may need to be scheduled for cooler times of the day. Wind direction and runway slope may need to be taken into account. Calculation. Density altitude can be calculated from atmospheric pressure and temperature. Where density altitude in feet, atmospheric pressure, standard sea level atmospheric pressure, true air temperature in kelvins, add 273.15 to the Celsius figure, ISA standard sea level air temperature in kelvins, lapse rate, gas constant, gravity, molar mass of dry air, National Weather Service equation. The National Weather Service uses the following dry air approximation of the above equation in their standards. Where density altitude in feet is the station pressure in inches of mercury, T is the station temperature in Fahrenheit. Note that the NWS standard specifies that the density altitude should be rounded to the nearest 100 feet. Easy formula to calculate density altitude from pressure altitude. This is an easier formula to calculate density altitude from pressure altitude and international standard atmosphere temperature deviation. Density altitude in feet equals pressure altitude in feet plus 118.8 x, where OAT equals outside air temperature in a degree Celsius, ISA temperature equals 15 a degree Celsius dash 1.98 a Celsius / 1000 feet XPA, considering that temperature drops at the rate of 1.98 a degree Celsius each 1000 feet of altitude until the tropopause, usually rounded to a C, or simply, DA equals PA plus 118.8, PA / 500. Plus OAT 15, or even simpler, DA equals 1.24 PA plus 118.8 OAT, 1782, where DA equals density altitude and PA equals pressure altitude, where PA equals HGT plus 30, 1013 QNH, and QNH equals nautical height equals height above sea level. Notes. References. This article incorporates a public domain material from the United States government document Pilot's Handbook of Aeronautical Knowledge. See also, outside air temperature, barometric formula, density of air, hot and high, list of longest runways, external links, density altitude calculator, density altitude influence on aircraft performance, NBIT Atmospheric Calculator, Android version.